Hello, geometers. I am here to help you remember some of your algebra skills that are a little bit dusty or rusty, and so that we can use them in geometry. And I just finished making a video about what you see on this page, about writing the equation of a line through a certain point that has a certain slope in slope-intercept form. Now, this didn't say in slope-intercept form, but I told you at the beginning of that video that I was going to do it in slope-intercept form first, because a lot of people prefer to keep everything in slope-intercept form. However, if this is the information we have, these two pieces of information, the slope and some point somewhere on the line, then there's really an easier way. The easier way, if that's what we have, is the slope and one point, is to write the equation in point-slope form, because that's what point-slope form is made for, is one point and the slope. So point-slope form of the equation of a line looks like this. Now, what does that mean? The ones with the subscripts, the x and the y that have the little number down beside them, those are representing a point. In other words, you have 1 point. So that's like 0.1. Okay? In other words, the point that I have, the x value is x sub 1, and the y value is y sub 1. That's my point 1, point number 1, basically. So I'm going to fill in x sub 1 and y sub 1, and m, and then I've got an equation. And if you're asked for your equation to be in point-slope form, then you're done. So y minus negative 7 minus a negative becomes plus equals, here's my slope, times the quantity, all of this together, x minus x sub 1. And if I'm asked for the equation in point-slope form, then I'm done. And that's it. So it's really tailor-made for this particular set of information. Now, what if I'm asked for the equation in slope-intercept form? Well, I really don't have to do a whole lot to get there from where I am right now. I'm going to take this equation, I'm going to distribute, and I'm going to move this guy. So let's go ahead first. That gives me negative 3/5 x minus negative 3/5 of 10 is 6. And then all I've got left to do is to move the 7 over. And before I do anything else, let me stop and go back here, because you may have seen the mistake I just made. This is negative 3/5 times negative 10. Negative times a negative, that's positive. So that should be a positive 6 right there. Okay, so now I'm moving my 7 over, and I have no more 7 on the left. That means y is alone. And on the right hand, I have this. Now it's in slope-intercept form, which is the same thing we got when we did it from scratch in slope-intercept form. Okay, so let's go ahead and try number 2 over here the same way. We're going to start out by using point-slope form. Point-slope form, again, looks like this. And it's really handy for just plugging in the point and the slope. So my point here, x1, y1, this is, let's go ahead and put that on there. x1, y1. So my y1 is 6. So y minus 6 equals, the slope is negative 2. And x sub 1 is negative 1. So x minus a negative 1. That's x plus 1. So this is point-slope form. That's the equation of the line in point-slope form. So if that's what you were asked for, you would be done now. If you need it instead to be in slope-intercept form, then we're going to distribute and then move the negative 6. So let's go ahead and do that. First, distributing gives me negative 2x minus 2. Then moving the negative 6, add 6 to both sides, and I have y equals negative 2x plus 4, which should be the exact same answer I got when I did the whole thing in slope-intercept form from the start. So this is slope-intercept form. So either way, you can end up at slope-intercept form. You can go ahead and just stick with slope-intercept form the entire way, which was what we did on this one, or you can go ahead and find it in point slope form and then change over from point slope form to slope-intercept form. Both ways work just as well. Hope that helps. See you later.